Engineering Eng. PDF document of this video is on engineereng.com.
Hello friends, I would like to write codes on how to do this video integral and derivative operations in MATLAB. If you wish, let's start these processes by opening a script file. Now let's write our classic commands first. Then we can do this in two ways, friends. Logically speaking, a derivative and integral question might look like this. For example, you get the integral of sinus x with respect to x. The result is minus cosinus x. You write a result with x, search for the integral and find it as minus cosinus x. The result I found here is a symbolic result. We have a code related to the combination of these four letters, which means symbols in English. After writing this code and saying what to take the integral or derivative according to the continuation and leaving a space, you can write x, a, b, c, etc. If you say, you can obtain your derivation and integral with such variables. There is another way. For example, there is cos x, and this is from 0 to p/2. This is the dx. This is the dx. Let's look at the integral of this. The integral of cos x is sin x, sin x. See, it is from 0 to p/2. You get 1 from sin p/2. Sin 0, I want. So you will find such a result. We will try to show both now. Now here we can divide it by 2 as a symbolic result using a symbol and numerical result using a numeric value at the beginning. Let's try to use it symbolically now. Let's try to get both derivatives and integrals. Now let's show it by doing the simplest operations. I say I have a symbolic value of x. This is how you write sims, and you determine your variable after leaving a space sims x. Then let's take a simple derivative. We derive derivatives with the common diff, guys. And whose derivatives I want to derive sinus x. What is my expectations? What is my expectation? Well, my expectation cosinus x come. Percentage, my expectation is cos x. Let's see if my expectation will come. Of course, this is a, b, c, etc. You can also equal the value. For example, you can say a to the result of this, or let's say a equals to sinus x outside, then you can take this part as a as follows: diff a. Nothing changes. Let's run this one. Now let's say lesson 12.1 here. Let's see, guys. As you can see, our result for a equals to sinus x ia sin x came in the form of cos x. My expectation is cos x, guys. Now let's write this directly as diff sin x to simplify it. In this way we can find the result without changing anything in the form of cos x. Let's say we want to get the Franz integral now. Let's say we want to get the Franz integral now. I typed int. Let's say the result of this is integral underscore result. Whose integral result am I trying to find? For example, let's be the result of cos x and cos x. Let's close this so that we can understand more easily. I turned off percentage. Let me delete that. Look more comfortable. Now if you say int, guys, you get the integral. We derive its derivatives with the diff command from differentiation. The derivative of sinus x came cos x. What is my expectation? My expectation is sin x to come, because I know that if I take the derivative of sin, it gives cos. So even if I integrate the cos, it has to give me the sin. Let's see if we got it right. As you can see, we can find sin x this way, guys. I got sin x, which was my expectation. Now, these were symbolic operations. Different kinds of things can happen here. Sin, cos, it is not necessary. I use sin and cos because they're basic functions. You can also use other things. For example, I could type int 3 multiply xx. What is the integral of 3 x uppercase 2? Guys, it is x upper 3. Let's see if we can see this. I wrote this for another function. As you can see, we get the result x upper 3 in this way, guys. Symbolic transactions are enough, guys. Let's do something else now. For example, let's say you were asked something like this time. The following question came to mind. They said, how about the graph of cos x dx? In what range? Is in what range? Question mark. What is the result in the range? Minus p to p. Now, what is actually being asked in the question? What is the integral of cos x? The result of this is sin x, because the derivation of sin x is cos x. Therefore, the integral of cos x is also sin x. Now, what he asks me is actually asking sin x, since it is the integral of cos x. It actually asks about the graph of sin x between minus p and p. So it asks me about the graph of sin x. But the question, it tells me from integral of cos x, I know the result of the graph here now, but I can just write sin x for a more difficult function. But I solve this in relation to x first, and then I plot it in the range minus p to p as follows. Now I have closed all comments and deleted. Look, I'm doing this now. I say sims, let there be a variable dependent on x again, sims x. The first thing asked me is the result of the integral. I find the thing to plot first. What's to be graphed, guys? I typed graphg underscore scratch. Whose graph is asking for me to integral? He wants the integral of cos x. So what am I writing here? I'm writing cos x. First, I have to find the integral of cos x. I need to find it based on x. We think simple, guys, are here. First, I calculate it this way. I'm saying, what's the integral of this? I know normally sin x will come, but it may be a more difficult function for you. Here, the function to be graphed is sin x. I learned that this is sin x. Now I say later, this time I save the x from being a symbol. How am I recovering? I will draw between minus p and p as follows. Minus pp 100/p. I divided between minus p and p into certain parts of p divided 100, so that the interval between minus p and is created to draw the graph. I learned what is the main thing to graph, friends. This time I take what I learned. I write it here. I say sin x, then I say card underscore sketching equals to sin x. Then I say plot, guys, for who with respect to x. I write what is to be plotted here like this. Plot x will draw graph. I put them long for clarity. Well, let's see this also from an angular angle. Graphics to come now. Let's add a grid to show this more properly. So did I have the correct graph drawn? Of course, I had to plot the sin x graph. Now I can confirm also in sin x. It is sin 90 equals to 1. Now I can see the 90 this time. So what do we do, guys? To convert this part from radians to degrees, it is multiply it by 100 and divided by, I convert it to 100 multiply x divided p degrees. If you ask whether it is doing multiplication or division first, it does multiplication first, but if you are not sure, you can close the part with the parentheses. So I first multiplied, then divided by, and now I converted all angles to degrees. Let's see this first. What am I going to look for the confirmation, friends? Does it give 1 in sin 90? Am I correct plotting sin actual integral of cos x? Look, it gives me 1 at 90 degrees. Of course, you can decorate the graphic a little more. I use the R command to draw in red and the line width command to draw a little bit bigger. I write 2 to make it draw 2 times thicker. You can draw it this way, friends. What am I drawing here is a kind of graph of sin x. But actually I have plotted the integral of int cos x, a function I don't know. It is important to draw an integral, because especially if you are dealing with electromagnetics, of course, in many other fields, the graph of integrals can be important in signals and so on. So there are usually things we call radians integrals. You need to plot the integral of these. So what is the result of integral? You can, an operation like this, how can I draw it? Now, I think, what else can we, after my friends, do it this way? We can do something like this. There are a few features about diff. Let's give it. I say it's a new script, guys. Again, I write my classic comments as usual. Since we usually use them for symbolic operations, I define an x like this again, symbolic, sims x. Let's do this for the symbolic x, for example. How many times you want to derive sin x, you write it after comma. For example, taking derivatives 2 times actually means that. So actually it asks me what is the result of integral sin x dx. The first is for the inside, the second is for the outside. Yes, the first is for the inside. Yes, sure. The second is for the outside. Yes, I take the inside first. It stands outside. I ask what is the integral of sin x? It is minus cos x. There was also the integral outside here. So what if I derive minus cos x comes? Of course, if I get the minus sin x. So the result of the double integral is minus sin x. For example, I have stated this process in this way. So if I say take the double derivative of sin x, what do I expect the result to be? I was expecting it to be minus sin x. Let's see if it will come. Let's record this as lesson 12.2. As you can see, we got minus sin x this way, guys. This way, friends. Let's find the result now. So let's find the direct result of an integral. How do we find it? I want to talk about it. I'm opening a new script. First of all, I will talk about what I will try to do, make it more concrete in your mind about integral. For example, I will talk about something like this, guys. Now, do I know the result of this, guys? Let's write something I know. Integral cos x dx is from 0 to p divided 2. There is a question like what is the result of this? I know this result is no longer symbolic but equal to the number. I know that a numerical result will come from now on, not symbolic like this one. Okay? I say I can solve this with my hand first. Let's solve it. I'm confirming it in MATLAB. The integral of what is cos x? Of course, in sin x. Now that I have the integral, I can write boundaries like this from 0 to p divided 2. Then I write upper bound, lower bound, sin p slash 2 minus sin 0. It is sin 90 equals to 1. It is sin 0 equals to 0. It is 1 to 0 equals 1. I'll try to find 1 now. How do we find? We find it a simple code, guys. We find it this way. Here you say, guys, I say integral, then you can say that you don't have to write one function or function equation. Your equation will have minimum and maximum values. I got it from 0 to 1 slash 2 right here. Let's show it again. From 0 to p divided 2, I say the lower limit is 0 and upper limit is 2. After specifying the lower limit and upper limit here, we need to define our operation at the top. We say equation equals to, we show the part where we show the variable symbolic. This is time using this sign. By typing this, we first indicate but the equation depends on x. Then I write here the x dependent equation itself. This is for us, if you remember, the cos x. Because what did I integrate here? I've gotten the integral of cos x. I go for result by result 1 by taking the integral of into MATLAB and validating it. So now everything is ready here. The question is ready. We say the integral. Let's see if we can find the result 1. Let's record this as lesson 12.3. As you can see, our equation is here. Of course, we could not show the equation here, the symbol putting. Only the answer came as 1, friends. Now we found this a single result, guys. There is also another command we use for integral. This is also a little different. This command is the traps command. For example, here is a command that includes steps between 0 to p slash 2, but that is we integrated by taking an array. Now let me explain the traps command here. The traps command works a little differently than the integral. The logic is these, guys. Now I say traps. I will do a transaction with traps, guys. Here's what I will do with traps. Let the value of integral cos x be from 0 to plus slash 2. So I will do the same with traps. Literally the same. In the traps command, I will say, traps and write our array. What we call array is that is variable x is written according to the function here. Traps. There is x cos x, we wrote this way. The logic of what we call traps is, guys, our variables x will look something like this. X will divide the lower limit and upper limit into a small pieces as possible. I'm defining an array now. It will start at 0, 1 and will be p slash 2. The smaller we take the steps between, the better, friends, will be. We find a result that is as close the result one we found with just the integral command a little while ago. So we are bringing us to some kind of main integral logic. Normally, what is an integral as logic, guys? For example, let's say I'm integrating from here to a to b. Integrating from a to b means take small little steps and finally find this field. So I find the area. The area below is found by an integral. The more I divide it into small pieces, the easier it is for me to find the area of this pattern. And the critical point here is, how small will I take the step in between? Small will I take the step in between? Let's take it with step p/10 once, and let's take it with step p/1000. We find the result close to 1, but a little farther in p/10 steps and quite close to 1 with p/1000 steps. Maybe it can show us the result to give the exact value of 1. So we can say that trap is a bit more a command in which the logic of the integral is written. So break the logic into small pieces and get area from those little pieces. Lower limit, get from pieces here instead of upper limit. Let's take a look at how we do this. Let's take these comments here. I'm opening a new script. I pasted them here like this. Now we do it like this, guys. My goal is again to find the integral of cos x. On the way to cos x, I divided the lower limit and upper limit of cos x in steps of p/10. X equals to 0, p/10, p/2. I'm preparing x like this. I get the traps command. I got the command traps, and I'm writing whoever integrates the x array with it. My aim is to find the integral of cos x. And let's see what is the integral of cos x. You can write the result here if you want, or you cannot if you don't want to. I will see it this way. I saved it as lesson 12.4. I saved it. Okay, let's see now. As you can see, friends, a little while ago we found the value 1 by subtracting the lower limit from the upper limit with the direct integral command. But now I have done the process in small steps in this interval. So I found it by doing the traps command in accordance with the definition of the integral. I found it quite close to 1, if not 1. But what do I know? I found point 18. Look, the value here is not exactly 1. Well, now I ask this. Here we took p/10 steps. I wonder if we took smaller steps like p/1000, how close would the result be to 1? I'm running it again, and look, my friends, gave exactly 1 result here. In other words, it gave the result 1, which we found with the direct integral instruction. So stepping in p/1000 steps from a to b, from 0 to p/2 helped me find the actual result. So our other alternative in traps is, friends, for integral. For now, these are basically enough for us, I think, in my opinion. Hope to meet you in another video. Goodbye.